Today we're going to talk about the fascinating world of prescription drugs and their intersection with culture and society. And for that, we're going to be joined by science journalist Thomas Goetz. Medications are some of the most consequential advancements of modern life, but their stories are often quite nuanced and complicated. What if some of our most common diseases are design flaws of modern life? In other words, we always need to be asking when we're treating biological illnesses and when we're medicating our way around the world that we've built. Also, does it matter if we are fixing a root cause versus just circumventing it? If a pill can quiet hunger or pain or anxiety, is that cheating? Do cures ever create the next crisis? So today we're going to talk about the larger stories of social ills and public health. Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and author at Stanford, and in these episodes, we sail deeply into our 3-pound universe to better understand the world around us. Generally, when we think about medicine, we picture a simple story, which is a disease appears, science identifies the cause, and a drug fixes the problem. But biology is sufficiently complicated that it rarely cooperates with stories that are that clean. Your body is trying to regulate hunger and mood and pain and sleep and anxiety. It balances internal signals against the outside world. But the fact is, that world has changed faster than our biology ever could. And we now live in environments saturated with calories and stimulation and stress and chemical shortcuts. And much of the world that we've built is designed explicitly to capture our attention and to override satiety and to make us feel better fast. So it's no surprise that many of the most common conditions of modern life, obesity, anxiety, insomnia, chronic pain, heart disease, are what scientists sometimes call mismatched diseases. In other words, we are ancient biological systems operating in a world that we weren't really designed for. And when those systems strain, we reach for medications. Now, prescription drugs are fascinating from a biology perspective because they are, in a sense, controlled perturbations. You stick some molecules into the bloodstream, and those cross barriers and bind to receptors and nudge the activity in some circuits. And then we watch what happens. Sometimes the effects are kind of miraculous. Other times they're subtle. And sometimes only decades later do we realize that a drug meant to solve one problem created some new problem. So we end up with medications for anxiety that tamp down fear, but they create dependence. We get painkillers that blunt suffering, but they cause addiction. We have sleep aids that knock us out, but damage our normal sleep architecture. Even the most elegant drugs can ripple through the system in ways that we never anticipated. Now, part of the challenge is scale. A lot of side effects don't reveal themselves until thousands or millions of doses have been taken. And part of it is just an issue of humility. Our biology is staggeringly complex. Even today, prescribing a drug is something like sending out a sonar ping and hoping the echo tells us something useful about what's happening beneath the surface. So this raises deeper questions. Are drugs treating diseases or sometimes treating symptoms of the world we've built? If a pill can quiet hunger signals or reduce cravings or lift mood or dull pain, does that mean the problem is solved or merely postponed? And what about responsibility when nearly half the population struggles with obesity, or when anxiety and depression are among the leading causes of disability worldwide? is it meaningful to frame these as individual moral failures? Or are we forced to confront the interaction between biology and behavior and environment and forced to rethink what choice really means? So these questions sit right at the intersection of medicine and society. So to dig in on these topics, there's no one better to sit down with than science journalist Thomas Goetz, who has just come out with a new podcast series called Drug Story. Every episode of Drug Story takes a single prescription drug like Ozempic or Xanax or Ambien or opioids and uses that drug as a lens to tell a much larger story, a story about disease and biology, but also about markets and incentives and unintended consequences. Thomas Goetz is an award-winning journalist. He's the former executive editor at Wired and the author of The Decision Tree and The Remedy. He's spent years reporting on medicine and science, and he has a special eye for connecting molecular mechanisms to human behavior and individual patients to systemic forces. So here's my conversation with Thomas Goetz. So Thomas, you've just come out with a podcast series called Drug Story. Tell us about that.
I spent the last 10, 12 years on an unexpected journey deep into pharmacy. So my background is in journalism and I have a background in public health, but I kept on thinking about the way we use drugs in our society to really treat problems which are manifestations of much larger problems. So when you think about the major kind of maladies of the modern life, like heart disease, diabetes, obesity, even things like depression or anxiety, a lot of these things are manifest because of the world we've built. But then the thing one of the things that we have to treat them are drugs. And so we have medications and we have prescriptions, and it works pretty well for some people. But it doesn't actually solve the root problems of what's going on. And so I thought the idea of the podcast is to use individual drugs to tell these larger stories about disease and society and economics and business, but really to focus on the drug as a kind of proxy or MacGuffin to tell this larger story.
So let's take an example of some of the drugs. You looked at the EpiPen for allergies. You looked at Ambien for insomnia, at Xanax for anxiety, at opiates for pain. What kind of through lines do you see when you examine these different stories?
Right. Well, with that group you just did, all of those drugs, oddly, have had pretty massive unintended consequences. So like EpiPen, EpiPen treats anaphylaxis, which is a allergic reaction, a severe allergic reaction. But the reason that we had this upsurge in food allergies over the last 20, 30 years was actually because the official guidance on food and possible allergic foods was exactly backwards. For 20 years, the American Academy of Pediatrics was recommending that parents avoid exposing their kids to peanuts and milk and eggs early in life. Well, then that was under the precautionary principle, the idea that they should, people should do no harm, and if something seems risky, then avoid it until the kids are a little older.
Cow's milk, I assume, yes?
Yeah, cow's milk, yes. Well, it turns out that was exactly wrong. So it turns out that early exposure is really useful and actually helps acclimate the body and the immune system to these possible allergens. And in fact, in countries where kids are exposed to things like peanuts from a very early age, there are basically no peanut allergies. So that was just this massive unintended consequences of well-minded, well-intended guidance that was just backwards. And so along comes the EpiPen, and it was perfectly timed to take advantage of this upsurge in food allergies. And along the way, they raised the prices, click, and made a lot of money, and then had congressional hearings. And there was a lot of outrage about the cost of drugs, which was really, the EpiPen was case A. But when you look at these other drugs like Xanax and Ambien, for instance, these were drugs that at the time when they first came out, they thought they were perfect pills. They thought they were almost magic pills. And because they worked really well. Like Ambien works pretty well to put people to sleep. And Xanax works really well to eliminate somebody's anxiety really quickly. But it turns out that these same medications, because they work so well, they create different human behaviors. And so people take them too much, they tend to abuse them, they tend to get tolerant to them, and it's really hard to stop using them oftentimes. So those are great examples of kind of the unintended results of using these medications in great amounts, millions of people, without enough kind of attention paid to what are the possible consequences.
Yeah, our society is like a giant dynamical system. And so when you push down over here, you get something else happening over here and so on. Would we have been better off without these drugs, though? Presumably not, because if somebody has insomnia or somebody has high anxiety or an allergic reaction, we still want to be able to help them. What's your take on that?
Yeah, totally. So yes, these are useful medications. The trick is how to use them. So again, thinking about Xanax or Ambien, they're really at this point intended to be used for very short periods of time when something is acutely wrong, right? So somebody is having a lot of trouble sleeping, then maybe an Ambien is appropriate to use for a very short duration, and then to remove it and come up with much more durable, sustainable solutions, like not using your screen in bed and things like that, more behavioral solutions. The trouble is that patients get prescribed these drugs and they work. And so the patient reasonably says, well, why can't I keep on taking these drugs? Where they're not necessarily cognizant of the dependencies or the tolerances that their body are acclimating to the drugs. So we have to think about these drugs not as the solution, but as part of a much broader kind of program or treatment program. And one of the problems that we have in medicine is that a lot of doctors are just not trained or don't have the time to manage individual therapies closely enough. And it's just a matter of time and man hours and billing, and it's the complexity of our healthcare system. But what happens in reality is people get prescribed a drug, they leave the doctor's office, it works, and they just keep refilling it. And so for those drugs that have potential abuse or dependency issues, those are really the ones that we need to work out or watch out for. And obviously opiates are a prime example of this. They really should have only been prescribed for acute pain, temporary, short durations, but they were widely prescribed for even moderate chronic pain, and people took them for months, years, and we had an epidemic of addiction.
And speaking of pain medications like opiates, where are we now with that? Now that opiates are considered persona non grata, what's the future of pain control?
One of the things about opiates that was again kind of an unintended consequence was that they were really widely prescribed when pain experts started to recognize that and argue that pain should be acknowledged, should be was worthy of treatment, because pain was really not considered, and doctors were not treating patients for their pain. So there was a program around the late 90s, early 2000s called Pain as the Fifth Vital Sign, where they instructed doctors, they were recommended doctors, ask people, just like they took their blood pressure or their breathing rate, they said, okay, a fifth vital sign would be ask your patients whether they're experiencing pain. And so it was a 0 to 10 scale. 0 is no pain, 10 is excruciating, unbearable pain. And doctors started asking their patients about their pain level. Well, that was wonderful in terms of flushing out a problem that a lot of people have. 25% of Americans deal with chronic pain. So it's a massive issue. The problem, the unintended consequence, was that once that was on the table, it became something that the physician was then obliged to treat. And different people had very different ways of rating their pain. So for me, what would be a 2 could for you be a 10. The doctor was really in no way of understanding what the relative concern was. But the treatment at hand at the time was opioids, and specifically OxyContin, which had just been approved as a supposedly safe version of an opioid. So it seemed like a great opportunity to use a so-called safe drug to treat a newly cognizant condition. Well, it didn't work out that way. It turns out OxyContin was highly addictive. People would abuse it rampantly. So opioids solved the problem, but as we've been saying, they created other problems. So now, or pain therapy they're trying to find new ways of dealing with, again, that very real problem for 25% of Americans. So there are new drugs. There are non-opioid drugs. There's a new one called Journavx, which was just approved last year, 2025, by Vertex Pharmaceuticals. It's a non-opioid peripheral nerve agent, so it doesn't work on the brain, doesn't work on the opioid receptors. They're very insistent and glad that it works on the peripheral nerve systems. The trick, though, is that is only been approved for acute pain, not chronic pain. So people can use it for 2 weeks, 4 weeks, but insurance will only cover it, will only pay for the drug for that amount of treatment. Now, I spoke for my podcast. I spoke to some patients who actually have found it very useful for their chronic pain, but they're paying out of pocket, and that's one of the problems. And it's about $1,000 a month to pay out of pocket, which is a lot of money. So the drug company is trying to get evidence that it works for chronic pain on a population level. They're trying to bring that to the FDA. That's a whole process that is ongoing. But we're still trying to find solutions to pain. One of the things that actually works, and again, you know more about this than I, but cognitive behavioral therapy for a lot of these issues turns out to be a very effective long-term solution. But the issues there are access to therapists, access to treatment. So there are consequences or concerns unto itself.
I mean, the good news is with apps and AI and so on, things like cognitive behavioral therapy can be addressed at scale now in new ways.
Totally.
Yet people still like, in a sense, taking pills. What's the attraction to saying, hey, here's a solution. I swallow this, I'm going to be fixed?
Well, it seems like an easy fix. And one of the things I learned was it's only really in the last 50, 75 years that we've had this kind of medicine cabinet of drugs. Like in most pharmacies, there are about 2,000 or 3,000 drugs behind the counter. A lot of those drugs have been only developed in recent decades. The big boom in the pharma industry was in the 50s, 60s, 70s, 80s, where we had these whole classes of drugs emerge. So they provided real answers, or apparently provided real answers to all these problems: heart disease, diabetes, the
psychiatric illness,
psychiatric concerns. So that's awesome. But on the other hand, we've only had a few years to understand what works best. And one of the things that has always surprised me is that the odds of any drug working for any individual are roughly a coin flip. It's roughly about 50% chance. So you go to something like an antidepressant, and there's kind of a 30% chance that any given antidepressant is going to work for any given patient. So what that means is trial and error. So patients are kind of start a drug. They take it for a few weeks. They see if it works. If it doesn't, they go to a different drug. If that doesn't work, they go to a different drug. Well, on average, it can take a person seeking treatment for depression, it can take them 6 months or more to find something that works. We talk about that as a process, but it's not exactly a process for the patient's experience, right? It's a kind of a trudging through darkness. It's a real struggle to get to something that works. And that's true not just for psychiatric conditions or chronic pain. It's also true for something like heart disease, because you have other variables like side effects, like diarrhea is probably the most common side effect to drugs. When you're taking chemicals, putting them into the body, your body reacts in some ways that are intended, some ways that are not intended. Sometimes you can tolerate those unintended consequences, sometimes you can't. So that all adds up into the recipe of, does it work? It's not just a clinical sense, it's like, does it work for you as a patient? And for most conditions, that is a process, and it's a messy one, and it's a muddy one. And it has a lot of frustration and anxiety and frustration to it.
It seems to me the central issue is that biology is insanely complicated, right? I mean, we often talk about the brain as the most complex thing we've discovered in the known universe. And so what we're trying to do is say, look, here's a molecule of a particular shape, and if you take a bunch of those in, they'll bind to some receptor, and what we're going to hope is that fixes this whole system, whether that's depression, anxiety, insomnia, whatever it is. And it seems almost impossible that will ever work. But sometimes nudges things in the right direction, or let's say for 50% of patients, as you mentioned. So what is your take on how you see the drug industry nowadays? Having been doing this drug story for a while now, how are you seeing this? Do you see drugs as miracles of biology that they work sometimes, or problems for society?
You're exactly right. These are complicated systems. You've got biology and the brain. Like the brain is even in these biological illnesses, the brain is still at play. Like just with allergies, there's this constant fear and concern about that people have before they take an EpiPen shot. People who have an EpiPen in their purse, they describe to me this whole thing about like, is a reaction EpiPen worthy? Because they just aren't sure if they should waste that shot or take that shot, which costs $300 or so. So there are all these psychological concerns that get wrapped up into the biological. So that's the first thing. But back to your question, like what about the drug industry? I think drugs are an amazing accomplishment of our society and of medicine and of clinical medicine and of public health, right? Like they save and treat thousands of people, millions of people every day in this country, around the world. They save lives. Full stop. Drugs are a benefit to society. The trouble comes when we expect drugs, as we just were talking about, like you take the pill and it's going to fix the problem. That isn't the way it works. On the one hand, biology isn't that simple. And two, it isn't fixing the larger problems of these deeper social conditions that oftentimes are creating the disease or the illness. So, there's this great evolutionary biologist at Harvard called Daniel Lieberman. You might know him.
I've read his books.
So he talks about these as mismatched diseases, that we've put our body, like we've designed a world that is very comfortable and accommodating, but it's not necessarily the world that our bodies evolved to inhabit. And so a lot of these diseases like heart disease or obesity are the results of the context in which we live. And so the diseases we're getting, like heart disease or obesity, are not the inevitable result of human life. They are the exact consequence of the world we've built, the food systems we've created.
So this is a good segue into GLP-1s.
Yeah.
So let's talk about that.
Right. So GLP-1s are, so I should say, when I started the episode on GLP-1s, Ozempic, I was...
By the way, for anyone who doesn't know, GLP-1s, glucagon-like peptide 1, and these are the drugs that people are taking for weight loss.
Yes, and they basically, you'll describe it better than I will, but I'll describe it in simplest terms. They basically interfere with the signal between your gut and your brain, and so they turn off your cravings.
That's exactly right. These are normal hormones that you have in your gut that tell the brain, okay, now you're full, go on, do the next thing. And the GLP-1 drugs are what are called agonists to these receptors. They mimic the action of these hormones so that they tell the brain, hey, no problem, you're full.
Well, I'm glad you're a neuroscientist. You explained it better than I would. So the GLP-1s, what they do is they because they interfere with that signal, they turn off what is called food noise in the brain. So they stop people from craving these foods that, to eat more and more and more. And they have other benefits as well. But
so what people feel like is, I'm just not hungry. I'm just not thinking about food.
Right. And so sometimes so people who oftentimes had spent decades trying to just not eat one more find it easy to not eat one more or not at all. And so it's been extremely helpful for individuals for who have been struggling for years, for decades, with being overweight, being obese, and the consequent health consequences of that, like diabetes, joint pain,
obstructive sleep apnea, all the things that come with obesity. That's right.
Just being able to move, just being able to live a active life.
And how many millions of people are on these GLP-1 drugs now?
Well, so there are about 40% of Americans are obese. So that's more than 100 million people. And so far, about 10% of Americans have taken a GLP-1. So that's 30 million people.
And when you say have taken, once you start, you really have to continue, right? So do you mean are taking or no?
For most people,
okay.
But it is possible, or for some people, I should say this, some people do have success in titrating in backing off where they reach their target weight, and they're able to then kind of maintain behavioral fixes that don't make them depend on the drugs. But yeah, for most people, they're going to be taking the GLP-1 for the rest of their life. Now there's nothing bad about that. There's no shame in that. If you are prescribed a statin, you will take your statin for the rest of your life. If you have a high blood pressure medication, you're going to be taking that for the rest of your life.
Blood thinners, rest of your life.
Yeah, exactly. Yep. So it's not that is one of the things that one of the ways we use medicine. But the thing about GLP-1s is it's very much an individual treatment, right? It is one person changing the way they eat, and it solves the problem for them. When you're talking about a population-wide problem like obesity, again, 40% of Americans being obese, soon to be 50%, you're looking at really huge social issues that when you are prescribing things like GLP-1s, which at present are very expensive drugs, it just becomes a really difficult proposition to think about, okay, well, how are we as a society going to afford that? And are there other changes that we could be making that would, given the amount of money that we would be spending, which is something like $1.5 trillion, if you put everyone in America who's obese on a GLP-1 at full price, it would be $1.5 trillion. So that's a lot of money. We could do a lot of things with $1.5 trillion, including change some of the food systems that we have. So you just have to think about the kind of trade-offs and costs.
So specifically what you're thinking about is you feel like food manufacturers have done things to optimize food for consumption, to make them salty and sugary and fatty and small and tasty and so on, so that you can keep going with it, right? This is what you're addressing.
Yeah, well, they have been doing that, right?
Yes, and so the point you're addressing here is that not only could we be addressing this with drugs with GLP-1s, but also doing something about the food industry. I do have a question though. How would you actually legislate that? Because what they're doing is making food so that people will buy that food and enjoy that food. And you can't exactly legislate to say, hey, don't make it as tasty as you have.
Right. So I'm not saying that you have to legislate it. I'm not saying that it requires government intervention. It could, but it doesn't require that. I think one of the things that's interesting that we're seeing is that when people take these GLP-1s and the food noise turns off, they independently change what they decide to eat. They eat more vegetables, right? They don't eat the stuff that is full of sugar, fat, and salt that is on the shelves, the ultra-processed foods. And so what you end up seeing is that the food companies themselves are trying to anticipate new products and develop new products that are, in fact, more healthy, more appealing to the millions of people who are taking GLP-1s. So that is a market-based solution, right? People are changing their behavior, and the industry is trying to change in turn. That would be wonderful if food companies develop healthier, less quote unquote less addictive foods that people would want to buy, and that don't end up manifesting in excess body fat and obesity. So some of that is market based, but there is possibly a role for FDA. The F in FDA stands for food. Food labeling is something that they govern. They can control kind of claims of being healthy. They can control claims of good for you, things like that. So there are ways that regulatory arms can be brought to bear.
Yeah, and it makes sense because when people are on GLP-1s and they start eating more healthy foods, more salubrious foods, it's because they know that they should be doing it and they no longer have the pull of this tempting sugar, salt, fat thing over there. So they're able to just think through the problem and make the right choice. And so making sure the labeling is correct so that something doesn't falsely say, hey, this is healthy for you, allows people to make good decisions, use their rationality there.
But I have a question for you, and I'm actually curious. What do you make of the idea that foods are addictive or might be addictive, that some foods could be addictive. Do you think that's true?
I do think it's true. What's interesting is people sometimes use the word designed there as in the companies designed the foods, but there's also a sense in which it's just evolved. It's a natural evolution that, people gravitate towards the things with more salt and fat and sugar and so on, and they like these things. So we've always had junky food like this, and we just have more and more of it. So this leads to this interesting question that you posed in your podcast, which is, does it seem like it's cheating to take GLP-1s? So first of all, what have you seen in your interviews and your research? Do people feel like, hey, this is cheating to take this drug and lose weight that way, as opposed to doing the hard work of going to the gym and resisting and using willpower?
So that is the debate. That has been the debate in part around GLP-1s. That has also been the debate around obesity itself for decades, that this was something that individuals should just, take control of their own free will, live better, exercise more, lose the weight. It's not that easy. And it hasn't worked that way, because that argument has been made for decades and the obesity rate has been climbing every year. So there's larger systems at play. Part of the problem, I think, with that debate is that, one, the foods actually are manipulating our brains in ways that are maybe outside of our personal control, that they are addictive in some sense, some of these foods. The other concern is that this debate around cheating is one where we are blaming people. There's still this this notion of blame and responsibility for obesity in particular, which we don't necessarily have. There's a lot of stigma to obesity that we don't have with other diseases. Even something like high cholesterol, which is often behavioral based, it doesn't appear, you don't look, when you have high cholesterol, it doesn't necessarily look like you do. So it's not as easy to attribute stigma. But it's also a particularly American problem or American argument about individual responsibility. Other countries, other cultures do not have as strong a history of individualism and individual responsibility, where there's two edges to the sword, that you both have the freedom to pursue your own interests, but also you have to be in control and suffer the consequences of your decisions and choices. That is a very American way of looking at individual choices. And again, Europe, other societies do not have as strong a strain of individualism. They have much more of a kind of commonality or communal notion of health and responsibility. And so they don't kind of have this culture of blame, which is a problem, again, uniquely American one.
So this is interesting, because it all comes down to this question of whether obesity is a choice, right? You're saying with the double-edged sword, you have all this freedom to do things, but also you're responsible for your choices. But this is really the heart of the issue: is biologically, there's a huge amount of variation on any axis that you measure. And some of these axes have to do with, for example, how much food noise one has, how sated one can be when one eats, and so on. There are genetic differences, there are, childhood differences, and so on. All these things add up to people being quite different from one another. So the question here is about choice, because this doesn't take away somebody's choice, but it does bound it. And this is, I think, the important part to recognize with all this, is that we all make choices and we're all bound, we're fenced in by our biology, and sometimes we're fenced in differently. So the answer is both. We're making decisions, but we don't come to the table equally.
But I totally agree with that. I would also say we're fenced in by our society and culture and by industry. So in the 1980s, Nabisco and Kraft, the two of the largest food companies in the world, were bought by big tobacco companies. And big tobacco brought all the science and engineering and marketing that they had learned in cigarettes to food. And so they started to create snack foods that were even better, even more irresistible. Now, you might say, that's just good business. That was just smart, expansion of their markets. But there was a recent study that actually showed that the food products that were sold by those companies when they were owned by Big Tobacco were actually 80% higher in salt, sugar, and fat than products that were owned by non-tobacco companies. So they were actually engineered to be very high in those ingredients because people like them, as you say, because that's what people are choosing. But at what point does that notion of choice and choosing certain products just because they taste better, just because we crave them, at what point does that stop being an individual decision and start being something that there are larger structures and forces at work? There's marketing in terms of the grocery stores and what's being put at eye level. That's paid for. That's placement. There's the commercials that we're being told these foods are irresistible, and that's a good thing. So those are all the contexts that I think also surround these ideas of individual choice that have a great deal of influence and have had a great deal of invisible influence on our diets and on our behavior in the past decades.
Absolutely right. And I think the way we can put this together is to think about the fence lines around your own behavior, given your biology. In the context of the world that you're in, some people will just have the capacity to watch a Doritos commercial and resist and not pick them up. And other people will watch it and they have so much food noise from that and they have so much craving and they're influenced by the marketing and so on, and they go for it. The question is, given your genetics and your experience, what is your capacity to resist and make good choices in the context that you're in?
Yeah, and it does have, there are socioeconomic variables here too. Wealthier people have more opportunity and more agency. One of your former colleagues, Albert Bandura, talks about self-efficacy, the ability to make our own choices, the confidence that we have to guide our own paths. That is something that wealthy people have much more of than people who are not wealthy. They more stresses in life. So those are all issues as well.
Just before we go off GLP-1s, my question is, there are all these other consequences that they're having that are extraordinary, like people are giving up smoking and gambling and other sorts of things. What's your take on this?
Well, it makes sense, right? Again, you're the neuroscientist, I'm not. But they seem to be things that are also affected by these pathways. So substance abuse, drinking alcohol to excess. These are all behaviors where we're hitting our pleasure centers, we're hitting our dopamine receptors, whatever it is, they work on our brain, and GLP-1s somehow turn it off. And I think they're just starting to do clinical trials in these areas. It's extremely promising. It's extremely hopeful for human health much more broadly. And remember, we're getting much stronger, better, more effective GLP-1s in the pipeline. We're going to start having oral GLP-1s, pills. Right now it's injections.
Yeah.
So once we get to pills and that are going to be more efficacious at fixing or addressing some of those behaviors, some of those issues, I think the doors are wide open to how these drugs are going to help us in the years ahead.
Now, by the way, you made a very interesting calculation in your podcast, which is that it would cost, as you mentioned earlier, $1.5 trillion to get, let's just say we're talking about obesity, to get everyone with obesity in America on these drugs. But what you calculated is why this might actually make sense to spend that money.
Yeah, well, that's, with a caveat, that's full list price. So, there are talks about doing deals with the drug companies to lower those prices. But roughly that $1.5 trillion.
Even if it were that, why would it be worth it?
Yeah, so the reason it's worth it, I think, is because we spend hundreds of billions of dollars. We spend $5 trillion on healthcare in this country every year, right? More than any other nation on earth. And out of that $5 trillion, we spend hundreds of billions of dollars on obesity. We spend hundreds of billions of dollars on diabetes, hundreds of billions of dollars on heart disease. So if we're addressing obesity, which is upstream from all of these other conditions, well, we would be chipping away at the amount we're expending on those issues, right? So it wouldn't be kind of erasing them altogether, but we would spend far less on diabetes if we had far fewer people going from obesity into diabetes. That's one point. But the other issue is really, I think, goes to kind of quality of life and quality of health span. Like, how do we help people have the best possible life that they can, the best possible health they can before they get sick? And that's one of the things that's so promising about these GLP-1s is they're really good at prevention. And so if we can help people pay that $1.5 trillion to give people better lives, instead of waiting for them to get sick and go in the hospital and, surgery and all these other things that we spend that $5 trillion on, that's probably a good argument to spend that money.
That was my interview with Thomas Goetz. Thomas's podcast, Drug Story, dives into many topics that we didn't touch on here, like Lipitor and heart disease, or Zoloft and depression, or Xanax and anxiety, or Ambien and insomnia, and so on. So I just want to summarize by hitting 3 issues. First, from the point of view of biology, every drug is a hypothesis. It is a guess. It's a carefully engineered intervention into a system that we only partially understand. We identify a receptor or a pathway or a circuit, and we nudge it. Sometimes the result is great. You get meaningful relief. Other times, the effects are delayed, or they're indirect, or they're only visible years later when millions of bodies have already been changed. The fact is that even with all the massive progress in biology, we still don't have predictable outcomes, and we're not going to for as far as we can squint into the future. We're always working to scratch out insight into a vast dynamical system that is shaped by evolution and development and experience. So when we intervene chemically, we always want to act on a single system, but we essentially never can. Instead, all we can do is perturb a system that's going to adapt and compensate, and that often surprises us. For the most part, medicine just can't tackle the complexity of everything happening under the hood, at least not yet. Medicine can't simulate the entirety of your biology, at least not yet, and certainly can't simulate your biology decades into the future to see what the long-term effects of drugs are or aren't. When you're dealing with exceedingly complex systems like the human body, it's just impossible to have certainty, and that's exactly why so many of the drugs on the market come with complicated stories that stretch beyond biology into societal issues. The second thing I want to point out is the question that is always there about the distinction between normal human experiences and medical conditions. If you have grief after you lose a parent, or sadness after some hardship, or anxiety in stressful moments, those shouldn't be thought of as diseases. Those are just appropriate human responses to life. They become medical diagnoses when they persist without a clear cause, when they become chronic, when they start to impair your daily functioning, like we see with clinical depression or anxiety disorders or chronic pain. In those cases, we can say, okay, the issue is not just a specific event or injury, but an ongoing physiological state, and treating it medically can both be appropriate and life-changing. And modern medicine has made unbelievably great progress in addressing these conditions with drugs as part of broader treatment approaches. But the boundary between normal human suffering and diagnosable disease, that boundary is subjective sometimes, and it's always blurry. And that raises really difficult questions about when treatment is warranted and how society decides which conditions justify large-scale medical intervention. And these are questions for which there are no simple or definitive answers. Finally, I want to highlight Thomas's view that many of the conditions we now medicate, things like obesity and anxiety and pain and insomnia, these are signals. They're messages from nervous systems doing their best to regulate themselves in a world that often pushes them out of equilibrium. Drugs can help. Sometimes they help enormously, but they also reveal the limits of a purely pharmacological solution. They remind us that biology and culture are never cleanly separable, and that treating downstream symptoms without addressing upstream causes is only going to take us so far. So, we're probably never going to find the perfect molecules that finally fix everything. But perhaps we'll get better at integration, drugs alongside changes that we're able to make in our environment, in our behavior, in our policy, in our technology. We'll get better at pairing molecules with psychology and neuroscience and social design. So, to my mind, one of the most important things about understanding prescription drugs is resisting simple stories, and Thomas does a good job with that. Prescription drugs have changed the world for the better, and also their stories can be complicated. So what we can do is keep researching. We can build bigger and bigger simulations with the help of massive computational models. We can leverage AI to understand those models. We can measure carefully. We can watch for unintended consequences. And that's what science does. It just keeps getting better. Such that in 100 years from now, when some future broadcaster makes Drug Story 2, the interplay between our drugs, our bodies, and the world we've built will hopefully be much more straightforward. Go to eagleman.com/podcast for more information and to find further readings. Join the weekly discussions on my Substack, and check out and subscribe to Inner Cosmos on YouTube for videos of each episode and to leave comments. Until next time, I'm David Eagleman, and this is Inner Cosmos.